7, 5 coordinate geometry. I can identify polygons on a coordinate.
Excellent job, Haddon. Appreciate that. Your mom will be very proud. Now, we didn't really talk much about polygons, but if we drew shapes and we could find slopes of the edges of the shapes and all that, I think would be good, right? Okay, I'm not really worried about the polygon part of it. All right, so here's what I need from you. Are you clear on slope?
Yes.
Do you know all the different ways to define slope?
Yes.
I can envision myself asking you a week from today on the test, give me 5 ways to define slope. Okay, and I think you're all good with them. You guys rattled those off pretty quick the other day. Parallel and perpendicular lines, again, I think we're pretty good. I think Miss Ackelman did a really good job when she showed you that also means perpendicular lines. Love that. Down here at number 2, this is a big deal. I don't know if it even makes sense for me to read through them, but number 4, number 5, number 6, and number 7, you need to understand what all of those are saying. So I'm not going to read through all of them because we're going to go to the next pages and we're going to look at the graphs and talk a little bit more about them. Okay, but these are very, very important notes. All of these are, I would actually consider cheat sheets. So when we go to problem number 9 on your graph, we plotted points. I'm not concerned about your ability to plot points such as these. Okay? I am really, truly not concerned about your ability to calculate slope, either by using the graph. So slope would be rise of 1, or rise of 2, run of 4. So what's the slope of A?
1/2.
Okay, and I do really think you guys can plug numbers into a formula. Change in Y over change in X. Yes or no?
Yes.
Okay. What I do want you to understand, though, is that if we have a slope of 1/2 here, and we have a slope of, what is the slope again?
1/2.
Because a rise of 2 and a run of
4.
So if we have lines with identical slopes, they are going to be what?
Parallel.
Okay. And then the other thing, obviously, that I'm going to want you to know would be if we have a perpendicular line. We know that this line's perpendicular, but how do we prove it? I mean, I can tell you, but the proof is going to be right here, right? So what is the slope of C?
-2.
What's the slope of C, everybody?
-2.
We said it's -2 over 1 or -2. You could also calculate it by doing rise over run. I can't find my points anymore on that. Right here. Boom, boom. Whoops. Let's try that again. So we got -2. If you calculate the slope of this line and the slope of this line, what's the product?
-1.
Okay. If you calculate the slope of this line and the slope of this line, what's the product of those two?
-1.
And we know that if we have a product of -1 when multiplying slopes, we have what kind of line?
Perpendicular.
And then the last thing, positive, negative, 0, and undefined. A horizontal line is what? As far as each of these options. Positive, negative, 0, undefined. What's a horizontal line?
0.
0, because the slope of a horizontal line is 0 over some number. Vertical line, slope is what?
Undefined.
Because a rise of something divided by 0 on your calculator gives you an error, right? Error means undefined. Is that technically an answer in math? Is undefined an answer?
Yes.
Is that a trick question?
No.
No, that's actually an answer. You guys know I don't believe in trick questions. C, to go from this point to this point, what kind of slope do we have?
Positive.
To go from this point to this point, what kind of slope do we have?
Positive.
We've got a negative and a negative, multiply them together, what do you get?
Positive.
Okay, so C is what kind of slope?
Positive.
And D is what kind of slope?
Negative.
So if I went from here to here, I have a negative and a positive. What's a negative and a positive?
Negative.
Okay, or if I went from here to here, we have a positive and then a negative, and that is a
Negative.
questions?